Welcome back to the VTC video training course on C++ fundamentals. We're going to talk about constructors for a few minutes here. The constructor is a special function that is called whenever you create an object of a certain class type, or you instantiate the class, and that's what actually makes an object in memory and causes it to come alive and do things. Well, the first thing that it wants to do is if it needs memory or needs to initialize some variables, things like that, those things need to get done in the constructor function. The compiler will provide an empty constructor if you don't give one yourself in the class. You probably, though, in more complicated classes, will want to provide your own constructor so that you know what's going to happen when somebody makes an instance of your object. We'll talk about destructors later, and they're going to serve cleanup duty. The constructor has the same name as the class. The function name is exactly the same as the class. We're going to see an example here in just a second. The constructor, again, creates all the variables, allocates any memory, opens connections, whatever you need it to do for this class object to be able to function. Now, a constructor never returns anything, and it has no return type, not even void. So nothing will ever come back out of a constructor, just so we know that. Here's an example of our little class again called C foo. And remember, we just have a capital C in front of it just to denote that this is a tag for a class. It's the name of a class. And we're not actually creating anything here. This is just like our old struct definition. Everything's going to be public now in this class because we set a public access specifier. And there is an integer I and a character C. And this is our constructor because it has the same name as the class. So that's C foo, and it will require an integer and a character. Now notice that this is just the declaration of the constructor, of the function. This is a function declaration. We haven't defined it anywhere on this page or in this translation unit. Somewhere there will have to be an actual function with open and closed braces that does something with the integer and character that come in. This is simply telling the compiler that when a class C foo is created, instantiated, an integer and a character must be provided to the program so that things can be set properly. In our case, I and C would have values put in them. So down here, we're going to use C foo, our little type now that we created, and make a C foo class object, just like we did in a previous example, and we'll pass in an integer, just the number 1, and a single character. This is good. This will work, and it will make one of these objects, and it will put an integer and a character in it and load them appropriately. This is wrong because we are creating another C foo, same class, trying to create another object, but we're not giving what we told the compiler has to be in here. We're not giving an integer and a character to the program when we create this thing. And that's one of the gems of C++ is that it will help protect you from doing things like this. Now obviously this is right next to where we created the class, so you'd think we could look up there and figure out that we need an integer and a character. But imagine if this is several files away or a continent away if somebody else is writing using the C foo classes and they're not sure what is supposed to be handed in here. Well, when it gets all compiled and linked together, the program is going to tell them that this is not right, that they need this integer and character in there. Let's take a look at what we need to fix that and make that work somewhat. We need a default constructor. A default constructor doesn't take any parameters into it, and then we can work with that. We can resolve it some way in our program and maybe set some default values for our integer and character, and then someone else using the class doesn't trip over it. They don't have to worry about that integer and character coming in. Now, if you want them, of course, to have to give you an int and a character or whatever other initialization type parameters, well, then don't worry about the default constructor. Let the program find the problem, and the compiler and linker find the problem and tell them about it right up front. But if you want to be able to create this class object without any parameters, here's where you do it. This is called overloading of this function. And overloading means that we create another function declaration here with different parameters. This one has no parameters. So when we come down here and create a cfoo, another cfoo object with no parameters, the compiler will do a lookup. And it will look at this and go, well, that needs an integer and characters. Does that match? No, that's not going to work. That's the constructor that it used when it created this object, though. But when it goes to create this object, another cfoo with no parameters, it goes through this list and says, oh, there's a constructor I can use, so it doesn't throw an error. And of course, we would also have to someplace define the cfoo function that does not have parameters, and maybe we would set these to initial values, the integer and character. We would do something to clean up properly and make sure that everything was still working. All right, so that's a constructor and what it does, and a default constructor. And we're going to keep on moving on and look at some other kinds of constructors.